And we're going to look at compound events and how that relates to probability. One of the sort of standout things that come out is that we're going to be using the 52 cards. So that's normal, like your normal deck of cards. So like that's the one with Queen, King, Clubs and Hearts. There's a lot of questions that ask that, so they almost know there's almost that knowledge that needs to be there. There's 13 in every suit, so if you got diamonds, hearts, and then you've got, if I change the color, I don't know, I need to get black. So, yeah. And then you've got clubs, and you got spades, which is almost like an upside down heart sort of thing with that sort of thing. So each one of them have 13 cards. All right. 13 cards. Also, each one of them has a king, queen, jack, ace, and then all cards from number 2 all the way to number 10. Okay, so that's the 13 cards there. And a lot of you will be familiar with that, but sometimes you need to remind people of that. Sometimes it's just like, yep, that's the first time I've ever learnt that. So, and that's fair enough. And we're going to also look at words like at least, at most. That's what sometimes gets students into troubles, and we'll just have a look at it and see how we go. So we're going to look at common events to calculate their theoretical probability. Okay. So hopefully by now you know the difference between theoretical and experimental. Often theoretical probability is the probability that you will be working with. So if you don't get what theoretical means, just treat it as normal probability and you hopefully will get there. All right, let's get started. Example, using a standard deck of cards, so the same things, because what is the probability of choosing a heart? So I'm going to use my probability notation and I'm going to go back to my red, okay? So I'm going to go probability of a heart, and I know that every one of the decks has 13 cards, so I'm going to put 13. And the total number of the deck of cards is 52. It says it to us in the success criteria. So it's 13 out of 52. And that will simplify down to be a quarter. Okay, which makes sense because it's one suit out of 4 suits. So the probability of choosing a heart is 13 out of 52. Okay, so just be aware of that for when we do our work. Now, what's the probability of getting an ace? I want you to pause and see if you can do it, and see, because some of you might be hitting your flow now with this kind of probability. A lot of students do that, and see if you can get it with the same amount, same as what I get. So I'm going to write I'll use a different color pen. Probability of an ace. Now I know that there's an ace of hearts, there's an ace of diamonds, an ace of spades, an ace of clubs. So there's 4 aces out of 52. Okay. But what we do have to do is that we have to simplify this down. So pop it in your calculator. I'm popping it into my calculator now. And you'll see that that's 1 out of 13, which makes sense as well because there's 1 ace per suit. All right. What about a king of spades? Well, I'm just going to write king, spades. There's actually only 1 of those cards in the whole deck. So it's 1 out of 52. All right. Now the next one is not a black card. Okay, so I'm going to show you how to do this. I'm going to draw a different color, purple. Black card. And the not is you have to write a hat on it. That means not a black card. So it means the opposite of a black card. So the opposite of a black card would only be a red card. And there's 13 plus 13, and that's 26 out of 52 total, and that simplifies to a half as well, which intuitively makes sense because half the deck is black, half the deck is red. All right, I'm going to do E over here. So let's go E. Neither a 4 or a 5. Okay. Now this is. I'm just going to go neither 4 or 5. Now let's think about this. That's a lot of cards. So all the cards that we want is everything but a 4 or 5. Now a 4 or 5 occurs twice in every suit. So there's 4 suits, so it happens twice here, twice here, twice here, twice here. So it happens 8 times, all right? So there's a couple of ways we can think about it. The way I think about it is I go 52 minus 8, and I work that out, and we get to 44, all right? So there is 44 out of 52 cards that are neither 4 or 5. And then what I need to do is I need to put this in my calculator, and I get 11 out of 13. And I'm going to rewrite this over here. Probability of neither 4 or 5. Okay? There's an alternative way of learning this, and that's that. You know how all probabilities add up to, like, the max you can get is 1? So you go 1 minus the probability of getting a 4 or 5, of getting 4 or 5, which we counted as being 8, because there's 2 in every suit. 8 minus 52. And if you put that in your calculator, it will come out as 11 over 13 as well. So either way works. I like to use it the first way, but you can choose whichever method you want. Okay, so let's look at this. Using a spinner, we're going to use this spinner. What is the probability of the spinner landing on? So imagine there's an arrow here that spins around, all right, just like I showed in the experimental probability video. He goes, what's the probability of getting a yellow? Well, yellow is 1 out of 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So probability of yellow is 1 out of a total of 8. Okay, let's look at what's the probability of not green, all right? So there's a couple of ways of doing this, but essentially there's 1, 2 greens. So not green, I'm going to use our notation, which is green, and put a line on top of it, and that means not. I'm going to show it means not. So the same as what is there. And so that looks like there's 6 left out of 8. And then we can simplify that to be 3/4. Now there's an alternative way of doing it. Please ask your teacher if you wanted to learn the alternative way. Otherwise, just do it this way because it works out pretty straightforward. Now the last question is probability of landing on green, yellow, and blue. So we've got green already coloured in, blue, I said that, and yellow. So that's everything now. So what I'm going to do is that I'm just going to go green, yellow, blue. Make sure you write it in this notation as well. Now there's 4 out of a total of 8 different spaces that the spinner could land on, and that can simplify it to a half. All right. So that's using compound events, and we can work on those things as well. Anyway, that's the end of the lesson. Peace out.